Good morning, dear students, and welcome to the geography class. And so here, this is the 6th chapter, rocks and the rock cycle. Already 2 sessions I have finished. This is the last session, but let's do the quick revision, and then I will finish this chapter. So this is the rocks and rock cycle. So here you are going to study about the 3 types of rocks. What are they? As you can find here, that is the igneous rocks, which is also known as the primary rocks, because it is formed directly by the solidification of the magma. Sedimentary rocks, which is also called secondary rocks, the first type, and metamorphic rock is also secondary rock, a second type. So these are the 3 types of rocks. You are going to study about these 3 types of rocks in detail. So first of all, let's see about the crust of the earth. So as all of you know, the solid crust of the earth is known as lithosphere. The word lithosphere is derived from the Latin word litho. Litho means rock, and so all the solid part, that is all the continents together, is called lithosphere. Well, now next thing we are going to see about the difference between the rock and minerals. So what are the rock? Rock may contain many elements, means many minerals, and it is also defined as an aggregate of minerals that forms a more or less definite unit of the earth's crust. In a simple or very simple definition, a short form, we can say rocks are an aggregate of mineral. So when we see about the rocks are formed by many types of mineral. Different types of minerals can be found in rocks. But when we talk about minerals, mineral actually is a single element. Single element, example, when we talk about iron. So iron is a single element, and zinc, gold, silver, or maybe manganese, mica. So all these minerals, they are a single element. But in a rock you can find all these minerals together in different percentage. So this is why this is the difference between the rocks and mineral. Now another thing, mineral has a definite chemical composition with its own chemical and physical properties. Why? Because minerals are a single element. But as the rocks, they contains many minerals, this is why they don't have any definite chemical composition, neither they have any chemical or physical properties. That is the most important difference between the rocks and mineral. So let's start here, first of all, the igneous rocks. So as you can find the word igneous, the word igneous rocks means the primary rock. These rocks are also known as primary rocks, and here you can find these rocks are formed by the solidification of the magma. Magma, that is molten material inside the earth, is called magma, but when it comes above the surface we call it lava. Well, now these magma, they are of 2 types, as you can find here, basalt magma and silicate magma. So when it comes above the surface we call it basalt lava and silicate lava, and when they solidified, so we will see it again afterwards, but let me just explain you. So basalt magma are the magma which is very hot and highly fluid. Well, the most important difference between the basalt magma and silicate magma, that is also known as the acidic magma. So the basalt magma and acidic magma is, basalt magma contains less silicate, while the acidic magma, which is also called silicate magma, and as the name suggests, it contains very high silicate and it is very viscous. Next is the types of igneous rocks. So as you can find here, the igneous rocks, they can be classified on the basis of structure of grains, chemical composition, and mode of origin. So first of all, we are going to see on the basis of silica present. On the basis of silica present, the igneous rocks can be categorized into 2 types. First is the acidic igneous rocks, which contains very high amount of silica. Example, granite. Second is the basic igneous rocks, which contains low amount of silica. An example is a gabbro. These are the two examples of the acidic igneous rocks and basic igneous rocks. Another classification is on the basis of occurrence. Occurrence means inside the earth, when the magma solidifies inside the crust, we call it intrusive igneous rocks. But when the magma comes above the surface of the earth, as you can find here in this figure, above the surface, this is called extrusive igneous rocks. Now, again, this intrusive igneous rocks is classified in two types. First is the plutonic and second is the hypobasal. So let me show you in the figure this magma chamber. When the magma solidifies in this chamber, there forms the plutonic rocks. But when the magma enters in the crust, means in the dike when they solidifies, or in the cracks they enters and solidifies, so these igneous rocks are called the basalt igneous, intrusive igneous rocks. So intrusive rocks again are of two types. In the magma chamber, when they solidifies, it is called plutonic rock, but when it solidifies in the close to the upper surface, that is upper crust, so it is called hypobasal rock. These are the two categories of intrusive igneous rocks. Next is the extrusive igneous rocks. So when we talk about the extrusive means the igneous rocks which are found above the surface of the earth. Now these rocks actually are formed either by the explosive way, means sometimes the volcano it explodes, and in that actually the lava and the ashes comes out. First of all the ashes comes out and then the lava. So what happened, these lava contains two things. First is the ash and second is lava. So this is a mixture of ash and lava, and they are called explosive type of extrusive igneous rocks. Second is the quiet type. Quiet type means in from some cracks when the magma continuously comes out very easily without any explosion, and that is a pure lava. There is no mixture of ash in it, and so when they solidifies, they are called the quiet type of extrusive igneous rocks. So these are the classification of igneous rocks. Now very quickly let's see some more different types of the intrusive rocks. As you can find, the batholith, that the large mass of igneous rocks found very deep inside the earth, and they actually covers about more than 100 square kilometer area. Another is the laccolith, that is dome type of mass. Then the sill, that is the horizontal layers when the magma enters in the cracks in horizontal layer. And the stalks, they are composed of the granitic rocks, and dikes actually are sheet like a body of intrusive igneous rocks. Now let me just show you some of them in the figure. And as you can see here, in this crack, as the lava enters and this magma solidifies, it forms sill. Then in the vent, actually when the magma solidifies, it forms the dike. At the same time, now already you know this thing, inside the earth, in the chamber, when the magma solidifies and it forms it is a plutonic rock, but it is also called the batholith. Now these are some examples. Now let's move to the characteristic of igneous rocks. So first of all, igneous rocks, they are solidified from the molten magma, right? Second thing, they are not found in the beds means they are not found in the layers. No layers are found, because only in one rock, that is the sedimentary rocks, are found in layers. And they are not fossiliferous, means they don't contain any fossils, because of the they are formed from the molten material. So what happens, all the fossils even they are destroyed, means they don't found, means no fossil is found here. Second, then the fourth point is they are very, very hard, and they don't allow the water to percolate, means they are non-porous. Next thing, they are granular and crystalline, because they are formed by the solidification of lava. As the lava gradually and sometimes very quickly it solidifies, so they are formed into granular or maybe crystalline. So they may be, these grains also can be the big grains or the very fine grains. Very fine grains, they form the crystalline, they are also called crystalline. So why the fine grain and the big grains? Because these magma, they solidify sometimes very quickly or maybe very gently, slowly. So in that actually the grains can be the very, very fine or maybe sometimes very, very big. Well, these are the difference. Next is they generally gets weathered by only mechanical weathering. Mechanical weathering means they are only weathered by the condition of weather, change in the extreme change in the temperature, or maybe by the agents of erosion, that is the running water and the strong winds, right? They generally weather these rocks. Next is the igneous rocks. They contain silicate, maybe less or high, but they contain some amount of silicate. Another thing, they also consist many valuable minerals like iron ore, gold, silver, zinc, lead, aluminium, manganese, mica. These are some important and valuable minerals found in these rocks. Next is the sedimentary rocks. So as you can find here, the sedimentary rocks are formed by the word suggests sediments. So when the sediments, like what are the sediments? Like the sand, soil, mud, clay, silt. When these sediments, which are actually weathered from the rocks, right, and when these sediments get solidified, they form sedimentary rocks. So usually these sediments actually are deposited in layers, and what happens, they solidifies in layers, and that is why these sedimentary rocks mostly are having the layers in it, and that's why they are also called stratified rocks, because the layers are called strata. That's why these sedimentary rocks are also known as stratified rocks. Now let's move and let's see the types of the sedimentary rock. So as you can find here, the sedimentary rocks, it can be classified in three types: mechanically formed sedimentary rock, chemically formed sedimentary rock, and the third is the organically formed sedimentary rock, in which you can find some example like sandstone, conglomerate, mudstone, claystone, shell. These are some example of mechanically formed sedimentary rock. Then the chemically formed sedimentary rock like limestone, dolomite, chert, and evaporites. Organically formed sedimentary rocks are the coal, petroleum, and natural gas. And here one picture is here. As you can see here, some pictures, some photograph of some rocks, like this is the limestone, and this is a picture of a chalk, and this is a sandstone. Now this is a mudstone, conglomerate, and this is a redstone. Now let's see about the first thing is the mechanically formed rocks. Mechanically formed rocks means when the rocks actually, maybe the pre-existing rocks like the igneous rocks or maybe the metamorphic rock, they go through the process of weathering and erosion. Now weathering and erosion is a mechanical process, and this mechanical process, the rocks are weathered into sediments, and these sediments are taken by this agent of erosion to some place, and they have been deposited. After wherever they are deposited, and when they solidifies, they forms the sedimentary rocks. So all the sedimentary rocks which are formed by this mechanically activity, that is the weathering and erosion, they are known as the mechanically formed sedimentary rock. Now here we are going to see some type of mechanically formed sedimentary rock. One is the sandstone. In this, what happened, the sand is deposited at some place, and when what happened, they get solidified, and there is one word used for the solidification, we call it lithification. So when they go through the process of lithification, the sand, so what happened, they forms the sandstone. Next is the conglomerate. In conglomerate, what happened, very small cobbles and the pebbles, when they just get solidified together, because, so you can say the cemented together because of the presence of calcium carbonate and silica. Like example, you can see here in this figure, as you can see here, so many small cobbles and the pebbles are there. They are cemented together, forms one rock, and this is called conglomerate. Next is the siltstone. Now when the silt gets solidified, that is lithification process takes place, and it is known as the siltstone. Now Next, let's see here. Now the next rock is the shell. Shell, as you can see, the mud stone. When the mud gets solidifies, so it forms the shell. Now these are the some examples of the mechanically formed rocks. Now next is the organically formed rocks. Organically formed rocks, example like coal. Then the calcium carbonate means the calcium carbonate in calcareous rocks. Example, the limestone and the chalk is a very typical example of calcareous rocks. So, and petroleum. So petroleum, coal, and the limestone and chalk, these are the some examples of organically formed rocks. Now how they are formed? Because during the Jurassic age, when there were found large animals, and all these animals were buried because of some activity, as I explained you in the previous class, right? Because of some comet actually which just strike the earth, and because of that actually what happened, all these animals and all the extensive forests, they were buried, and after the long time what happened, they just converted into fossil. So the thing is, the calcareous rocks, all the bones of these big animals actually just change into calcareous rocks, and these plants actually they just change into the coal, and also in the layers of the rocks what happened, they also turned into petroleum. So this is how actually these rocks were formed. Next is the chemically formed rocks. An example is the salt. There are different types of salt is there, like there is a black salt, there is a one in Hindi, there is a one we call it sendha namak, that is so we also call it rock salt. So rock salt actually is a very typical example of chemically formed rocks, because what happened, as the water gets evaporated and the salt actually gets remained left behind, and what happened, it solidified and forms the rock. There are so many examples actually in the Dead Sea, in the Aral Sea, and the Caspian Sea, and the Sambar Lake. There are so many examples of the rock salt is found. Well, next is the Aeolian sedimentary rock. So as all of you know, Aeolian means the deposition done by the wind. When the wind carries the very fine particles of soil and deposit at some place, so that soil is called loess, and that deposition is known as Aeolian. Now what happens, when this loess actually it gets solidifies, it is called Aeolian sedimentary rock. These type of rocks actually are very common in the Huanghe Valley, that is in China. Next is the glacial sedimentary rock. So what happens, as all of you know, as the glaciers they move, they also erodes the surface of the rock, and these all deposits are brought down, and these deposits are known as the moraines. Moraines means the red sand which usually you can get in the market. All of you know about the morang, in Hindi we call it, but that is moraine. Well, sometimes actually this moraine actually they get accumulated and they solidifies and they just forms a rock, and those rocks are called glacial sedimentary rocks. Next, the petroleum already we have discussed, that is the rock oil. It is also called the rock oil. How it was formed? By the product of the decayed vegetation and the plant remains, as I explained you. Now next is the rock salt. So as you can see, the rock salt that is formed by the evaporation in the saline lakes, the water gets evaporated and the salt which was left behind gets solidifies and forms the rock salt, and this is the example of the chemically formed rocks. And last one is the coal. As I explained you, this is the example of organically formed rocks. Now next is the characteristic of sedimentary rocks. So very quickly we will just finish it. So as you can find here, the material actually, the sedimentary rocks usually they are derived from the parent rocks, means the igneous rocks and the metamorphic rocks. When they go through the process of the weathering and erosion, what happens, they just turn into sediments, and when these sediments get solidifies, they form the sedimentary rocks. So usually all the sediments actually that is called the material that is usually obtained from the parent rock. Parent rock means the igneous rock and the metamorphic rock. Now usually the sedimentary rock you can find, they are found in layers, and they are also solidified in layers, and that's why already I explained you this is called, that's why they are also called stratified rocks. Now these, because of the tectonic movement, actually usually the sedimentary rocks are found in the horizontal layer, but sometimes actually because of the tectonic movement, what happened, some places they are also found in tilted form or maybe even lateral form because of the compressive and tensional forces. Well, next is the sedimentary rocks. Actually usually you will find they are deposited in the rivers and in the sea also. Now sometimes actually they can form big structures like boulders. Cobbles means the smaller rocks, pebbles are much smaller, granules means very small rocks, and then the sand, silt, clay and the lime, these are the example of the deposition. Well, these are, next is the sedimentary rocks. They are also characterized by the joints, because as I already explained you, they are having the layers, and these layers are joined by some joints. So that's why joints are very generally very common in these layers. That is, layers are also called bedding plane. Well, next is these rocks are permeable, means they are porous, they allow water. The water very easily can pass through these rocks. Now next is the sedimentary rocks. They contain fossil. Fossil means, as I told you, the fossil fuel like the coal and the petroleum are found in sedimentary rocks, in the layers of sedimentary rocks. As I told you, actually the remnant parts of the plants and the animals, right, they were buried under the soil, and what happened, they get solidified under the layers of the rocks, and so these sedimentary rocks usually contains fossil. That's why these rocks are also known as the fossiliferous rocks. Now next is these rocks, they can be well consolidated. Well consolidated means they can be very hard. Poorly consolidated means they can be very weak in structure, and even unconsolidated means they can be very softer in nature. So these sedimentary rocks, they can be very hard, even they can be soft, and they can be weak in structure. Well, next is the riverine sedimentary rocks. Near the river, actually, when the sedimentary rocks, when the silt, actually when the clay, they get solidifies into rocks, what happens when they gets dry, so they just forms the polygonal shape of the cracks. That's why these rocks usually they are having the found in polygonal shape. So this is about the sedimentary rock. Already I have finished this thing. Now let's start with the metamorphic rock. Now what happens here? What is the metamorphic rock? When the sedimentary rock and the igneous rocks, as they go through the process of metamorphism, means when they go through the process of extensive heating and pressure, what happens? They forms the metamorphic rocks. So there are the example. So usually, let me just show you some example here. This is one example. As you can find, slate is example of sedimentary rock, but when it is exposed to the heat and pressure, they just turn into shell. Even the schist also is the example of the metamorphic rock. But what happened? The shell, actually they are formed by the shell. Shell is exposed to the intense heat and the pressure, and they form schist. So all these examples, slate, schist, quartzite, marble and gneiss, these are the examples of the metamorphic rock, and they all are actually formed either by the sedimentary rock or by the igneous rocks. Okay, now let's see here the causes of metamorphism. So usually the metamorphism may caused by the volcanic eruption, during which actually when the magma comes out, so because of the intense heating, what happened, the rock, when it comes in the contact with the lava, they just go through the process of metamorphism. They get solidified, means they change into metamorphic rock. Next, in the mountain building movement also, as all of you know, during the mountain building movement, what happened, the tectonic movement takes place, right, and because of that the folding activity occurs. In this, actually the surface of the earth, it gets folded, means the wrinkles are formed on the upper surface. In that, actually very intense pressure is caused actually because of this intense pressure, which is really caused by this movement in the earth. What happened? The metamorphism takes place. Then the endogenetic forces. Already I explained you that the whole earth actually is divided into different plates, and all these plates, they move in different direction. Now because of this movement in these plates, what happened, there are sometimes very intense pressure is created between the two plates, and what happened, many places sedimentary rock and the igneous rocks, they turned into metamorphic rocks. And next is the contact with the undergoing water. As you can find, sometimes very hot rock, right, when it comes into the contact with the very cold water. So very quick change in the temperature that brings the metamorphism in the rock. And even sometimes actually near the volcanic region, because where the springs and the geysers are very common, so usually the spring and the geysers, they are having very hot water, and the temperature of water can be more than 5000 degrees centigrade. Now in such a intense heating actually, when any rock, when it comes in contact with this water, very hot intense hot water, so what happened, the metamorphism takes place, and sedimentary rock and the igneous rocks, what happened, they turn into metamorphic rock. Well, these are the 4 causes: organic eruption, the mountain building movement, endogenetic forces, and 4th one, on contact with the undergoing water. Now next is, let's move to the characteristic of the metamorphic rock. So as you can find here, the first characteristic is metamorphic rocks actually, they are formed actually and change occur actually. And what happens here, suppose there is a sedimentary rock, when it changes into the metamorphic rock, in that actually both the texture and the mineral composition both gets changed, they don't remain the same, both gets changed. Example, limestone, when it turns into marble, you will find they are totally different, right? Next is there are some example actually in the metamorphism. What happened, maybe if sedimentary rock or igneous rocks, they go through the process of metamorphism, so they becomes more harder. So usually the metamorphic rocks actually are much harder than the original rocks, from which they get metamorphized. Now next is the fossils actually are not found in these metamorphic rock. If the fossils are present in the sedimentary rock, so what happens when they go through the process of metamorphism, so all the fossils, they get destroyed. Next is the coarse grains. As I told you, the metamorphic rock, they contains the coarse grained, right, and because of this actually they are imperfectly foliated. And so example, there is one more example, this point actually, let me explain you here in this different way, right? As let me give you one example, and let me make it easier for you. Now if you will find here, these are the 3 types of rocks: slate, then schist, and gneiss. All these 3 rocks, they are formed by the same sedimentary rock, shell. In all the 3 cases, shell is there. Let me show you another point here from your book. And if you will find here actually, as you can find, the shell can involve a series of steps depending on the intensity of temperature and pressure. So because this change depends upon the different intensity of temperature and pressure, now the same shell can change into not only slate, but it can change into schist and even gneiss. So these are the 3 types of metamorphic rocks. They all are formed by the shell. But why it happens? Because in this process, the different amount of heating and the pressure is involved, and that actually different types of metamorphic rocks were formed. Now this is what that point actually that means. Now next is the another point here. This metamorphic rocks actually, whenever the metamorphic rocks are found, suppose in the sedimentary rocks, as I told you, sedimentary rocks are found in the layers, that is the bedding plane, and whenever they get metamorphized, means they are formed into metamorphic rocks. So what happened, the layers are broken. That's why actually the split actually, they metamorphic rocks, when they are formed, so these rocks get split. That's why they are never found, metamorphic rocks are never found in the layers. Well, next is the metamorphic rocks are impervious. Impervious means these rocks are non-porous, they don't allow the water to pass through them. Well, now let's directly move to the types of metamorphism. Now there are the 4 types of metamorphism. So the first is the thermal metamorphism. What is the thermal metamorphism? Now thermal metamorphism, what happened when thermal metamorphism takes place, when this metamorphism takes place only due to the high pressure, Now, that is thermal metamorphism. Very good example is graphite. Another one is the dynamic metamorphism. Now this metamorphism takes place only due to the high pressure. Now very good example is diamond. Now in the coal mines, in the coal fields actually, due to some tectonic movement, what happened when excessive pressure is created? So what happened? Because the coal actually is the carbon. Now too much pressure is created and they are compressed, and what happened? Diamonds are formed. This is a very good example. Next is the contact metamorphism. Contact metamorphism, when sometimes the sedimentary rock and the igneous rocks, they comes into the contact of some very hot magma. As the lava flows, all of you know the basalt lava is in a liquid state, and it can flow to a large distance. So as the lava flows, and whatever rocks, especially the sedimentary rocks, when it comes in contact with this hot lava, so what happens? They turns into metamorphic rock, and that is example of contact metamorphism. And very good example is marble. Now whenever the hot magma, that is lava, it flows in some limestone region, so what happens? It bakes the limestone and marbles are formed. Next is the regional metamorphism. Now usually in the earth, in the mountain building movement, usually what happens? All of you know that there is a lot of too much pressure, that is compression movement, and tensional forces, they are involved in it. And because of that, actually what happened? The rocks which are found above the surface, because of the folding activity, they can be taken deep inside the earth, and where they can go through the intense heating and pressure, and what happened? They can turn into metamorphic rock. Now that is a very good example. That is a regional metamorphism. Well, this is called regional metamorphism. Now all the metamorphic rocks actually, they are of great use. Example, you can find the marble or slate or the phyllites or quartzite or mica. These all rocks are of great industrial use, and in construction purpose also you can find these rocks are used. Now next is the rock cycle. Now just to explain you the rock cycle, usually this thing can be defined as a cyclic process of changing the form of rocks is called rock cycle. But let me explain you with this figure. Now here you can find here that actually these are the three rocks: sedimentary rocks, this is the igneous rocks, and this is the metamorphic rocks. But what happened? These sedimentary rocks actually, when they go through the process of melting, it changes into igneous rocks. When these igneous rocks, they go through the process of intense heat and pressure, they change into metamorphic rock. And again, these metamorphic rock, when they go through the process of weathering and erosion, they again change into sedimentary rock. Now this all activity doesn't take place in a short period of time. Now usually if you find about the earth history, so earth history is about million years old, right? Billions and millions, not only million, but we can say many billions of years old. And this is why actually this cycle have continuously it occurred there in the earth history. And another thing, one more thing you can find in the another way also, igneous rocks, when they go through the process of weathering and erosion, they turn into sedimentary rock. Now sedimentary rocks, when they go through the process of heat and pressure, they turn into metamorphic. Again, this metamorphic rock, through the process of melting, again can change into igneous rock. So this is a cycle, either this way or this way. In both cases, this is a cycle actually, and this cycle is called rock cycle. Now next is the economic and geographic importance of the rocks. So you can see here the first importance is, if you take the example of all types of soil, maybe the silt or maybe all types of soil, either alluvial soil or black soil. Now these all soil actually is very fertile. All agricultural activities are carried in soils. Now how these soils are formed? These soils are formed due to the weathering and erosion, that is the denudation, as I explained you. And we can call by the process of disintegration and decomposition of rocks. So this is how actually when the rocks, they turn into soil, silt or mud, they can be very important for the agricultural activity. Now next is these rocks contain so many different types of metallic minerals like gold, zinc, copper, iron. They all are extracted from the rocks, and they are so important. At the same time, rocks also contains the minerals like coal and petroleum. Now coal and petroleum, they are called the energy mineral, right? They are very essential in the industries, both of them, not only the metallic minerals but also these coals and petroleum. which is also known as the energy mineral. Okay, both are very, very important. Now next is the there are so many another example of raw material, like example of the limestone, gypsum. They are very, very needed in cement. Cement actually is manufactured by these two minerals. And many minerals are mixed in that, but two very important minerals which is found in the cement is limestone and gypsum. Then the coal and the manganese, or maybe iron ore, they're all important. Bauxite actually is rock, and bauxite is used for what thing? For extraction of the aluminium. So aluminium industry depends upon bauxite rock. So like this, actually all these minerals actually they are extracted from the different types of rocks, and they are very, very important in different industries. Next is the rocks actually are also important in the construction of the roads, or maybe the construction of the buildings, or the roads, or maybe the dams. In every construction, even one simple house, you can find different types of rocks are needed. In the kitchen you can find there's a granite is being used outside on the floor, lawn, or maybe the roads. Different types of rocks are there. The sheets are being used. Okay. Next is the very, very precious metals like gold, silver, diamond, platinum. They are all actually extracted from which rock? Different types of rocks. That is the rock. Okay. So like this actually, because they are very, very important in making jewelry. So this is the geographic and economic importance of rocks. So this is how this chapter is finished.